Hello everyone, I am Bhargav. Today, I am presenting EMISSARY, Enhanced Miss-Awareness Replacement Policy for L2 Instruction Caching. This is a joint work by Nayana, Ishita, Atmn, Svilen, Tipp, Jared, Gilles, and Professor Simone Campanoni from Northwestern University and my advisor David August from Princeton. Modern server workloads have large core footprints, due to which they face huge front-end bottlenecks. Here is a top-down analysis of a well-known database application, Cassandra. It shows that only 17% of issued instructions are retiring, and 54% of issue slots are lost only due to front-end bound events. Upon a closer look, it shows that latency is a big problem, which means that front-end is unable to supply instructions due to iCache misses. This is mainly because data center workloads have code footprints larger than the size of L2 cache. To tolerate instruction cache miss penalty, modern processors implement fetch-directed instruction prefetching pipeline. Here is an example state of FTQ from cycles 0 to 14, and entries that miss in iCache are shown in red color. Observe that R0 and R3 both miss in instruction cache, but the effective miss cost of R0 is 10 cycles, whereas the effective miss cost of R3 is only 1 cycle. It shows that not all misses have equal cost. What are the kind of lines that are causing these stalls? Here is a distribution of all lines by the reuse distance. A short reuse line would hit in L1, a mid reuse line would hit in L2, and a long reuse line would miss in L2. When we look at stalls caused by these categories, we see that 90% of stalls are caused only by 15% of lines. This shows that only a small subset of lines are responsible for huge number of stalls. Our key insight that not all misses have same cost have been explored in the context of data cache lines, but not for instruction cache lines. Combining this insight with our key new insight that only a small subset of lines are responsible for a huge number of stalls, we propose EMISSARY. EMISSARY delivers a geomean speedup of 2.5% across 13 data center workloads, which is 16% of unrealizable L2 cache with a 0 cycle miss latency for all non-cold instruction accesses. To know how we do this, please attend our full talk in Session2B on Monday, June 19th at 2:30 p.m.